Yes. Okay, hello guys, and hope you are doing okay. I want to run this unit, prepare and interpret technical drawing, some aspects on the last aspect that I did not cover in class. So first I'll have to start with some brief introduction of what you're supposed to do, the things to cover from the previous term, that is term 2, and also term 3. So on to our next slide. I divided the unit into two sections, theoretical and practical session. So in theory, you have to define the term technical drawing. Of course, we defined in class. It's an art, and it's a universal art that can be used by different types of engineers so that they can come to a common understanding. If it's a drawing, then symbols used, the units used have to be universal. Then you have to know the importance of studying engineering drawing. So as you study something, it has also its importance. Then you have to know the lettering, then the tools and equipment used in technical drawing, types of dimensioning techniques, principles of dimensioning, and the title block. So that is the overall overview of the introduction part. So if you move to the next slide, the theoretical session. I'll start with the theoretical session. It's a common question in section A, roles of engineering drawing today. And I always advise you to give complete statements, not hanging statements at least. So if you asked about roles of engineering drawing today, one, it gives the ability to read and prepare engineering drawings. Then two, to develop the skill of making freehand sketches of objects. Three, creative ideas can be recorded by means of engineering drawing. Four, it develops the capacity to understand other subjects. Then five, it enhances the power to imagine, analyze, and communicate. So those are some of the 5 roles of engineering drawing. So if you look at each of 5 roles, most of them are applied during the practical session. If you look at the first example, it gives the ability to read and prepare engineering drawings. As you use different types of symbols, and that's why I always emphasize in class that you use a British standard form of symbol so that it can be recognized by any other engineer or any other person performing the drawing or who comes to interpret the drawing. Then to develop the skill of making freehand sketches, as you perform continuous drawings, you'll discover that you'll develop that skill of making freehand sketches. And most of the questions, section A, and most of the CEDA questions that you have passed through in class, they revolve around making freehand sketches of hand tools, drawing equipment. So that is also one purpose or one role of engineering drawing. Then creative ideas can be recorded by means of engineering drawings. That aspect can also be seen from our recent topic, the orthographic projections. When you are talking about three-dimensional objects, so you have the hidden details. So you have to be very creative in order to determine a hidden details in an image, be it an isometric projection, that is an isometric block drawn in 3 dimensions, and also a 2-dimensional object. Then number 4, it develops the capacity to understand other subjects. If you look at engineering drawing, we also do some electrical circuit, we also do some schematic and wiring diagrams. So what we study in the engineering drawing is just how to draw the circuit, but more of that knowledge you can be able to understand better when you are dealing with other subjects. So for example, if you are drawing the motor control circuits zenye tulichora kwa class, both power and control, you'll find that most of those circuits resemble the ones that are being drawn in electrical principles, electronics, and machines. So if you are able to understand a circuit from those units, you can be able to draw it also in the engineering drawing. Then it enhances the power to imagine, analyze, and communicate. So if you are looking at the aspect of imagining something, and that we apply mostly when we are dealing with orthographic projections, drawing diagrams in first angle and third angle. So if you are given the views, you have to imagine to look at those views in 3 dimensions, because most of those views, as we discussed in class, we said an orthographic projection is a type of projection that has only 2 dimensions, that is the length and the width. So if you have to draw an isometric projection, that is a block that has the length, width and the height, then it means you'll have to look at those views in 3 dimensions. So that is also another role or another application of engineering drawing when performing drawings. So to the next slide, we look at the methods of expression of engineering drawing. Hii question ilileta kwa cut 1, cut 2 na pia end of term last term, na watu wakuwa na perform vizuri. So we have 3 methods of expression of engineering drawings, one being freehand sketching. Freehand sketching ni ile you use your free hand to make a sketch of an object and it has some marks in it. And I discovered that as the time goes by, most of our lessons we used to do freehand sketches. Before I could start a class, I could tell you to sketch an object. So with that, I'm testing you on the skill of, are you able to sketch something? And you have seen the majority of questions that you have passed through in class, that is the CDAC examination questions. They always test on making freehand sketches of hand tools, the ball pen hammer, the claw hammer. So you have to know exactly how those tools look like so that you can be able to draw it in a sketch. And then I also say that at least you have to make the sketches they should not be so tiny, because most of you guys, you draw sketches that are very tiny. It has to be at least medium. So not so tiny, not so big, at least medium size. At least inside the components can be able to be seen. So that is one, freehand sketching. Then we have the use of drawing instruments. So the use of drawing instruments, we have the instruments that you are told to come with during your admissions. That is the T-square, the set square, that is the 2 pairs of set squares, the engineering set, the French cups. So those are some of the drawing instruments. So that is also another method. One method you can freehand sketch, another method you can use the drawing equipments, and those drawing equipments can be drawn onto a drawing paper. Then the third part is the use of computers. So you can be able to also to produce engineering drawings using computers. And for computers, we have an installed software that is called the AutoCAD, which enhances us to make the drawings as required. Then after knowing all those methods of expressions, we come to the standard drawing paper sizes. So we said that since engineering drawing is an art, depending on the quantity or depending on the amount of diagram that you want to draw, that is it, looking at the space factor. So you'll have to use a different set of papers. So for drawing papers, we say they are labeled with a prefix A, that is capital A. So we have A5, A4, A3, A2, A1, A0 or A0. So if you are told to list the standard drawing paper sizes that are used in engineering drawing, you have to list a list with the prefix A in its initial step. That is, one you can say A5 in brackets 148 by 210 millimeters, another one A4 210 by 297 as you go by. And we are looking at the trimmed size of a standard paper. Then we will go to the standard boards. So the standard drawing boards are labeled, or they start with a prefix capital B. So you have the B0, B1, B2, B3, B4. So after knowing that, we go to the next slide. So the next slide I've given an illustration of how the different types of papers are. You have the A0, which is slightly bigger. that is the biggest. We come to A1, then A2, A3, A4, then A5. So depending on the diagram that you need to draw and how it can fit, so you can use a different set of paper to illustrate that. Then next we go to lettering. So lettering is an important part of drawing and is essential in writing titles, when dimensioning an object, and also in drawing the title block. So you have to observe a correct form of lettering. And the drawing, even if drawn neatly and accurately, its appearance as well as its usefulness may be spoiled because of poor lettering. So you might have drawn something that is very neat, your diagrams are very neat, but your lettering are very poor. So depending on the examiner's way, the lettering has some marks. So you'll be denied some marks because of poor lettering. So you have to really observe a good collection of lettering so that you can be able to scoop the marks that are needed also. The lettering should be done properly with clarity, uniformity, and legible styles. So if I'm talking about clarity, the letters should be clear. If someone is very far away from the drawing, you can be able to see that this is capital C, this is capital D. That is being clear, that is the clarity. Then uniformity, the letters should have a uniform size. The letters should not be in such a way that you have others that are big and you have others that are small, or you have others that are straight and others that are slanting. Then it means you are poor in lettering. In order to perfect on this, use the maximum height and a midpoint line to make them best. And thus I always encourage you in class that before performing any lettering, make sure that you use a height of 10 millimeters. You can use a height of 10 millimeters as the maximum height. I always label it with capital H. Then we have the small h, the midpoint, as the 5 millimeters. So if you draw these two lines, they can be able to make your letters stand upright, and at the same time they will be uniform. No letter will be bigger than the other. So that is also an aspect that really needs to be observed. On to the next slide, we look at the drawing instruments. So the drawing instruments used to prepare drawings accurately and easily. The accuracy and quality of drawing depends upon the accuracy and quality of the drawing instruments. So your drawing instruments should be very neat and at the same time very straight, so that you can be able to produce accurate results in terms of drawing. If you use crooked rulers, then it means that your lines will not be perpendicular when making the lines. Then you have basic tools. The basic tools, these are vital tools that are commonly used when performing any drawing. You cannot perform any drawing without them. So you have one as the drawing board. You will require the drawing surface where you need to place your drawing paper. Then next you require the drawing papers. Then you have the pencil. Under the pencil, I illustrated on how you can use the different types of pencils to draw the different types of lines. So you have the 2H, the HB, and the 4H. Then you'll have also an eraser, so that in case you make an error, then you'll require to rub the error and also rectify on it. Then you'll have the masking tape. The masking tape we use normally to mount the drawing paper on the drawing board, so that it is in an alignment with the T-square. So this one, it is essential in making perpendicular lines, both horizontal and vertical lines. Then you have the engineering set. Inside the engineering set, you have a set of tools, pair of compasses that are used to perform engineering drawings. Then you have the set squares. The set squares, they are used to measure angles. At the same time, they can be used to draw very short horizontal and vertical lines. Then you have the T-square. The T-square, its main function can be used to mount the drawing paper on the drawing board, and also making long horizontal and vertical lines, especially when you are drawing the border line or the outline of the drawing paper. You require the T-square. Then you have drawing straight lines. You require the T-square, the set square, mini drafter, and scale. When drawing curved lines, you require the compass, the French curve. In our recent session you saw how we used the French curve to draw the ellipse. So we had the three methods of drawing ellipse. One was the 4-center method, then we had the eclipse method, and then the final was the rectangular method, but we only performed the two. So with that you saw how a French curve is also important when making such curved lines. Then you have measuring distance and angles. You can use a pair of dividers, scales, and protractor. So as you move to the next slide, I've done some drawing there on lettering. So I discovered that when you are marking your papers, most of us could make some errors when making drawings or lettering. So you'll find that most of the letters are slanting, some of them are unfinished, and some of them are crooked. So at least when you are making your lettering, you have to look at the letters should be upright, should stand first, they should stand upright, not slanting. Then if you look keenly, you will see that I have a maximum height of 10 millimeters and a midpoint of 5 millimeters. So it shows you that that midpoint is the one that is making me to make all my letters uniform. So I made the capital letters, that is A to Z, and also the small letters. You can now see the usefulness of that midpoint line. If you are drawing a small Q, it will not be the same as drawing a capital Q. And at the same time, when making the numbers, that is from 0 to 9, and I'll really emphasize on number 4, because if you look at the way I've drawn the number 4, the midpoint has made me achieve that because it is uniform. So that is how you should also be doing your drawings. Make sure that first, all your letters are upright. Then second, all your letters are clean and clear. If someone can see your drawing from a very far distance, they can be able to determine that this is a D, this is an E, this is an F, this is an G, J, O, P. So I discovered that most of you were weak when drawing the capital F, the small f, then you have the small q, and then capital K. So that is how you should make your drawings when doing the lettering. So on to the next slide, I've given out a drawing paper layout. Into that drawing paper layout, I've shown you that if this is the paper, then there is that space that we give from the outer edge of the paper to the border page or to the borderline. So we always give a distance of 10 millimeters. Then your title block should be drawn on the extreme bottom right corner of your drawing paper, observing those dimensions. That is the maximum width 50 millimeters, the maximum length being 120, then the subdivisions being 70 millimeters. So as you may go into this end of term, make sure that you observe that layout, because there is a mark for the title block which is always marked out of 4 marks. So you might end up losing the 4 marks. And I always say that in any drawing, since it's an art, every mark counts. There might be a point where you can get 46%, and since you displayed a good title block, we can add the 4 marks to that 46% to make it 50%. So everything that you do into that piece of paper, it's an art and has some marks in it. Then next, we look at the types of lines. In our previous class, we discussed on the different types of lines that are used in engineering drawing. One is the outline or the borderline. So I said the outline, this is a bold line that is continuous in nature and is drawn on the outer edge of the drawing paper. That it shows the boundaries of the drawings. So you cannot draw an object that exceeds the outline. It's called an outline or a borderline. Then you have the dotted lines. The dotted lines, when we were doing the first angle and third angle projections, you saw me draw the dotted lines to display a hidden detail. So you can be viewing it from a front face. You will discover that there is a hidden detail that cannot be seen on the hind face. So it means that you'll have a dotted line to show that. Then we have the center line. The center line is used to dimension the center of a circle, and it's illustrated by short and long dashes that are uniformly spaced. So if you are drawing any circle, make sure that at least if the question has told you to dimension it, you'll have to use a center line. Then we have the dimension line. The dimension line, they show the extent or the stretch of the object. So the dimension line are always, they have arrowheads on both ends, which are bolded. So if you draw a dimension line that has no arrowheads, then it means it ceases to be a dimension line. It can either be an extension line or a projection line. So if you come to the projection line, these are lines that are drawn in perpendicular to the edge of the object on either sides of the object, and it can also indicate the border of an object. So from there is a note that I have given you that in case you are told to dimension, there is a question you can be asked. Copy the image below and insert 5 major dimensions. So it means that as you draw that picture, the moment you are doing the dimensions, you'll have to first draw the projection lines to show the extent or the limits of the length. Then after you have done that, you'll have to, from the object, you'll have to leave a space of 10 millimeters, which is equivalent to 1 centimeter. Then you draw your dimensional line. So with that, it will enable you to avoid the confusion of knowing the exact length of the object and also to avoid overlapping of lines. Then you have the long break lines and short break lines. The long break lines, I said, they used to indicate a large break in a thing, and they are drawn by zigzag lines. Then the short break lines, they are in equal borders and a small break in a thing, and usually drawn by hand. Most of these short and long break lines are drawn by the hand. And I gave you an example of the heartbeat. If you are told to draw a curve of a heartbeat rate, you will not be able to measure the heartbeat and say that it has a fixed amplitude, simply because the heartbeat rate varies. Maybe if someone is walking or running, the heartbeat will vary. So there is no uniform amplitude. So that one can be drawn by the use of a short break line and also by the use of a long break line. So after understanding the types of lines, now we'll move to the next part, which is the title block. I'll really emphasize on the title block since I told you that the marking will be done as a block. So at least an examiner has to see that you at least underwent through a class of engineering drawing and you are taught how to design a good title block. So for this, I've just designed a sample of a title block where I've included the name of the institution, that is Kiambu National Poly, the name of the student, your admission number, then I have written end of term, then the date, then the drawing number 3. Drawing number 3 meaning that this is the number 3 exam that you're doing. Then the scale is to 1:1. We have not done any reductions or expansion of scales. So we always use a scale of 1:1 because the exact units that we are being told to measure is the exact unit we will transfer into the drawing paper. So a reduction scale, it's always it's applied in a place where, let's say you are told to design a house, and a house, if you look at maybe the wiring of a house, and you cannot draw 50 meters on a drawing paper. So for you to come up with that scale, you will do what is called a reduction. You always do a reduction scale. You will say let 1 centimeter represent maybe 2 meters. So that if you divide 2 meters by 50, then it means that you can be able to draw that distance of 10 centimeters on your drawing paper. But that 10 centimeters will be representing the actual 50 meters on the ground. So the exact scale that we are using here is 1:1. not 1:10 like other people used to say 1:10, 1:50. No. So it's 1:1. The exact units that you are being measured, you are told to measure, is the exact unit you transfer into the drawing paper. So next we go to the final aspect, which is the dimensioning techniques. They are arranged in three. You have chain dimensioning, parallel, and combined. So I told you that if you have drawn an object and they have told you to dimension it, there are some few rules that you need to observe. First of all, the dimensioning units to be used are millimeters. So we do not use centimeters anywhere. So if you dimension an object and you are putting centimeters in it, then it means you will fail that particular aspect. Then each feature should be dimensioned at least once on a drawing. To avoid over dimensioning of an object, you just have to dimension once. And I said that if you see there is a longest side and inside there they have some partitions, it's not necessarily that you have to dimension all those partitions. What you can do is you can dimension the whole length, that's something that is visible, and then you leave the others. Then you have the dimension should be placed in the outside of the view. Of course, when dimensioning an object, you do not dimension an object inside the object, but the dimension lines should be from the outside, at least spaced with a distance of 10 millimeters, which is equivalent to 1 centimeter. Then no gap should be left between the feature and the start of extension line. So if you're drawing the extension lines, you have to make sure that all the dimension lines touch, all the arrowheads in both sides touch the extension lines. So no gap should be left. And then dimension should be taken from visible lines and not hidden lines. So you cannot use hidden lines such as the dotted lines to show that you have dimensioned an object. You have to use a thick continuous line. Then all dimensional objects describing a component should always be clearly laid and completed on a diagram. So if you're dimensioning, make sure that you have to write the units. If it is 20 millimeters, the dimension shows that the starting point to the ending point is 20 millimeters. So you have already shown the dimensional feature of that line. So you should not draw a dimension line, then at the same time leave it hanging. So that is just a brief overview of the introduction part. On my next tutorial, I'll be giving on the practical part, where I'll need to emphasize on some few things. So on this coming end of term, at least let us make sure that we come up with good drawings, that is in terms of lettering, a good title block, we observe neatness, and of course, since it's 2 hours, we always have to observe time when performing drawings. I told you of a very simple scheme that you can use when making drawings, and I hope that you can use the same skill, and you'll discover that even the 2 hours is a lot to do drawing. So I discovered that most of you waste your time to draw a title block, which you can use it maybe approximately 5 minutes to draw a title block. Because if you take 30 minutes to draw a title block, which only gives you 4 marks, you forget that the entire paper has 80 marks in it. So it's better to do faster. Make sure that you use the least time possible to draw the title block, then come draw the borderline, then start performing the actual drawing, because there is where the actual mark is. So after that, I told you of a good process of tackling questions. Once you're given that paper, don't be in a rush to start doing the questions. Always scan through the questions. Look at the questions that you can do with ease. If there are 20, tick all of them. Those questions that you cannot be able to do with ease, you can be able to start, but you cannot be able to complete. You can have a complete tick, but with an X, showing that this question I can be able to do it, but I cannot finish. Then those questions that you can completely not do it, you can put an X. Then as you start making the drawings, start with those questions that you can be able to do faster. Give the examiner the hard time to look for questions. You should not start in sequence, and since you start with number 1, you have to go to number 2. So if you can start with number 1 and the next question can be number 2C. So it's okay with that, because at the end of the day, as long as you have done all the questions, then the mind, as I told you in class, the mind will always open when you start with the simplest to the more complex. And the mind always reminds itself from the things that you learned long time ago to the things that you have learned current. So that's how the mind is programmed. And if you can be able to go through those questions the same way, you'll find that even those questions that you were unable to do it, the mind will start opening. And that's why most of the people fail, because they might have maybe a hint on the exam. They go through that hint, they go cram it. So they come singing that thing in their heads. So when they finally come into the exam room and they find that it's the first question in it, a small panic switches off the mind, and the mind goes back to reset mode. It's like it's being reset. So that person cannot even be able to draw a symbol of a fuse. You find that he draws something that is not resembling a fuse because of the panic. So always use that process. Go scan through the paper, go through those questions that you can do with ease, tick all of them. Those ones that you can do it but you cannot finish, tick with an X. And then those that you cannot completely do, make an X. And then after that, start doing the paper, and you'll discover that you'll use the smallest time possible to do the questions. Otherwise, I hope this video finds you in the best place to revise. See you in the next video.